Hello class, today we're taking a look at our BEDMAS and Exponent Laws Readiness Guide. So the first two questions here deal with that first lesson of this half of the unit where we're looking just at our BEDMAS with powers, roots, all those types of things. In question A, what we want to remember is that we do need to treat the fraction as having these implied brackets around the entire top and entire bottom. The division of the fraction is going to be our last step. So if I take a look at that top there, I'm going to have my negative 16 plus. I need to do my exponents inside that brackets first. Negative 3 squared is negative 3 times negative 3, which would be positive 9. On the bottom, I've got my 6 take away 2 is 4 squared, and then negative 3 squared again there is 9 on the bottom. Okay, and we are subtracting that positive 9. So when we evaluate that, we're going to have our negative 16 plus 9 is negative 16 getting less negative by 9, or negative 7. On the bottom, we're going to have 16 minus 9, and that'll be positive 7 on the bottom. And negative 7 divided by positive 7 is negative 1 as our value. Question B, we want to start inside these brackets. So our 12 divided by negative 2 is going to be negative 6 inside the brackets. Next, we'll evaluate our two exponents here. Sorry, that's exponent 3. Okay, 6 squared, of course, is 36. And our 6 cubed is going to be that 36 times another factor of 6. 18 plus 3 is 21. So this will be negative 216. So our negative 216 is the value of our power, and we do need to subtract the value of that power. So when we subtract a negative, we're going to use our add the opposite rule to complete that integer subtraction. So it's really 36 plus 216. 6 plus 6 is 12. 1 plus 3 plus 1 would be 5. And then 200 plus nothing, so 252. Okay, question C, longer, but same idea. So again, we're going to start inside our brackets. So our 5 take away our 27 is going to be negative 22. Inside those brackets. Next thing we're going to do is our exponent inside the brackets. So 3 cubed is 27. Inside those brackets, and 27 plus a negative 22 is positive 5. Of course, in each of these steps, we still have everything else that wasn't being evaluated. Okay, next thing we're going to do is evaluate our exponents in the rest of our expression. So 4 squared is 16, 2 cubed is 8. Still got this part in the middle, a divide sign, and then negative 2 cubed is negative 8. Now, next thing in our BEDMAS is going to be our multiplication and division from left to right. So we're going to go ahead and say, okay, well, our 8 times 5 is 40. And our 40 divided by negative 8 will be negative 5. So we got 16 plus 8, subtract that negative 5. So this is really 16 plus 8 plus positive 5 by our add the opposite rule. 16 plus 8 is 24, plus another 5 is 29. Okay, next one here is going to be our question D. Good. So again, we're going to start inside the brackets there. We're going to do our exponent inside the brackets first. So our negative 4 squared would be negative 4 times negative 4, which is positive 16. Next, we'll do our multiplication inside the brackets. So 2 times our 16 is going to be 32. And 32 take away 2 is going to be 30. And we need to cube that. So let's start with the fact that I know 30 squared is 900. And so I need to do my 900 times my 30. And of course, this is just going to be 9 times 3 with 3 extra zeros on it. So 9 times 3 is 27 with 3 zeros after it. You could actually do the long multiplication here if you needed to. Just going to move that a bit for our posted version. Okay, now remember your square root, again, has kind of implied brackets. So anytime we have more than one thing underneath that square root, we need to do all of that stuff together and then take the square root of our single number. So let's go ahead and evaluate there underneath our square root. 5 cubed is 125, 5 squared is 25, and 125 take away 25 is 100. So we got our square root 100 plus our square root 36, all squared. Square root 100 is 10, square root 36 is 6, 10 plus 6 is 16, 16 squared is 256. So again, just using our memorized facts there to help us out where possible. Okay, and this last one here, again, looks pretty ugly, but there are some tricks in it. For the first thing, I know that this thing has an exponent 0 on it, and anything exponent 0 on it is 1. So that part of my fraction will be nice and easy. Okay, I do know that 2 plus 3 is 5, so that's going to be our 5 squared for that part. On the bottom, again, I do know that anything exponent 0 is 1, but I do have that negative coefficient in this particular question. And then this is 5 squared times 8 minus 3 is 5. So let's use a bit of exponent laws here to help us out. So 5 squared times 5 squared is 5 to the 4, times 1 is still just 5 to the 4. Here we've got our negative 1 times 5 squared times 5, so that's negative of 5 cubed. Now remember from your first unit that when you have a negative in a fraction, you can put that negative in any one of 3 places, including out front of that fraction. And that's what I'm going to do here. Oops, sorry, that's a 5 cubed. Now that 5 to the 4 divided by 5 cubed is just 5 to the 1 by the quotient of Powers' law. This is just negative of 5 to the 1, or just negative 5. Okay, in your question 2, this is your place value, or your powers of 10 rule. And we know that any power of 10 is just a 1 with that number of zeros after it. So when we have 3 times 10 to the 4, it's 3 times 1 with 4 zeros after it. So this is going to be 30,000. Okay, 5 times 10 squared is 5 times 100, or 500. 8 times 10 to the 1 is just 8 times 10, which is 80. And 9 times 10 to the 0 is 9 times 1, which is 9. So we're going to write a number that has 30,000. Nothing in the regular thousands place, 5 in the hundreds place, 8 in the tens place, oops, no comma there, and 9, oops, no comma there again, 9 in the ones place. Same thing over here. So we've got a 6 in the thousands place, we've got a 1 in the hundreds place, we've got a 5 in the tens place, and a 3 in the ones place. So again, just use your place value rule there with your powers of 10. Okay, question 3 should be really easy. We want to look for, do we have the same bases or same exponents for our different power laws? So in question A, I see that my bases are both negative 8. When I divide powers with the same base, I can subtract their exponents. And 12 take away 4 gives me exponent 8. Make sure you still have that in brackets, because of course we do need to connect that negative to the base 8. In the case of question B, I don't have the same bases, but I do have the same exponents. And when I have the same exponents, I can combine the bases, keep that exponent. 9 times 3, of course, being 27, exponent 3. Exponent 7 was our exponent. Same thing in question C. I don't have the same bases, but I do have the same exponent. When that's the case, I can combine my bases and keep that exponent. So 24 divided by negative 8 is negative 3, exponent 5. In question D, I'm going to use my power of a power law. When a power is raised to another exponent, I multiply those exponents. And so this will be negative 7 to the 15. Then when I have the same base and I'm multiplying powers, I'm going to add their exponents. So this will be 5 exponent 10. I'll leave it to you to look for an error in question 4. But remember, you want to look for things like, did they apply their power laws correctly? Are they adding, subtracting, multiplying, dividing as appropriate with their exponents? Maybe they were combining things with different bases when they shouldn't have. Look for all those types of things. Another way of doing this is just to copy the question down yourself and work through it and see where your answer differs from the given answer. Okay, question 5. We got more exponent laws here, so we just want to work through in BEDMAS order for the operations on our powers. Question A, we've got multiplication and division, so we're just going to work from left to right. When we divide powers with the same base, we subtract their exponents. So this part will become negative 2 to the 10. Obviously 12 take away 2, giving us that 10. And then when we multiply powers with the same base, we're going to add their exponents. And so this will be negative 2 to the 10 plus 3, or negative 2 to the 13. Question B, we do not have the same bases here. Well, excuse me, we should start inside brackets, and inside those brackets we should do our exponents on powers first. So we're going to do this piece first. When we raise a power to another exponent, we multiply their exponents. 6 times 2 is 12 there. Copy out everything else in the expression. 3 to the 8, excuse me. Then inside those brackets still, when we divide powers with the same base, we're going to subtract their exponents. 12 take away 8 gives us 3 to the 4. And that was everything inside those brackets. Everything we have left is multiplication and division, so we're going to work from left to right. So when we are multiplying these two powers with the same exponent, we can combine their bases. 12 times negative 2 is negative 24. And keep our exponent of 4. And then again here, we've got our same exponent 4 in both of those. So again, combine our bases, and negative 24 divided by 3 would be negative 8 with that same exponent 4. Question C, again, you want to remember your implied brackets of your fraction. You can leave it as a fraction if you want, or you can go ahead and write it as division. In this simple question, I'm going to choose to leave this as a fraction. On top, I'm multiplying two powers with the same base, so I'm going to add their exponents. So a plus 12 is 20. On the bottom, I'm again multiplying powers with the same base, so I'm going to add their exponents. 13 plus 4 is 17. To finish up there, when I'm dividing two powers with the same base, remember your fraction is just division. We're going to subtract exponents. So this will be negative 3 to the 20 take away 17. 20 take away 17 is just 3. In question D, we are going to start inside our brackets. So we know that our 8 squared times 4 squared, we can combine those since they have the same exponent. This will be 8 times 4, which is 32 squared. And then we've got our exponent of 3 outside there. When I raise a power to another exponent, I multiply their exponents together. So this will be 32 to the 2 times 3. 2 times 3 is 6. And then to finish off this division, I have here two powers with the same exponent, so I'll combine their bases. 32 divided by 16 is 2 exponent 6. In question E, we want to go ahead and start with our operations inside brackets. I could simplify that and say that that's 2 exponent 4, which would be fine. I know that anything exponent 0 is 1, so I'm just going to go ahead and replace that whole term with just 1. Now going back to my power laws, when I multiply two powers with the same base, I'm going to add their exponents, so 4 plus 2 is 6. Then I don't have any power laws for adding or subtracting powers, so I'm just going to have to evaluate everything from here. I know that 2 cubed is 8, and 2 to the 6 is 2 groups of 2 cubed, so 8 times 8 is 64. 2 to the 4 is 16, and plus 1. So 64 take away 16, well 64 take away 10 would be 54. Take away another 6 gives me 48, plus 1 gives me 49. Then finishing up here, we're going to start inside our brackets. So here we've got two powers with the same base. We're going to subtract their exponents. Next, we're going to do our multiplication of these two powers. They do have the same base, so we'll add their exponents. 4 plus 2 is 6. And from here, we're going to go ahead and just evaluate. Now, you might notice that we already did these calculations because negative 2 to the 6 is going to be positive 64, and negative 2 to the 4 is positive 16. 64 plus 16 gives me 80 overall. Now, I do believe we were asked to evaluate some of these earlier ones. So simplify, then evaluate. So we would want to go ahead and do that for our different problems here. So we do need to evaluate, for example, in question A, B, C, D. Some of these are nice and easy. We already calculated that 2 to the 6 is 64. So we can go ahead and put that in. Negative 3 cubed is going to be negative 3 times negative 3 times negative 3, which is negative 27. Get those in there. Negative 8 to the 4. That one is a little bit harder, but I do know that that'll be negative 8 squared all squared. I know that negative 8 squared is 64, so I want to do 64 squared, or 64 times 64. 4 times 4 is 16. 4 times 6 is 24 plus 1, 25. 24. 36 plus 2, 38. 6, 9, 10, 40, 96. So this is going to be positive 40, 96 is our evaluation. If we take a look at our negative 2 to the 13, let's think about some of the powers that we know for this. I do know what negative 2 to the 6 is. That would be 64. So I'm going to break this up into negative 2 to the 6 times negative 2 to the 6. And I need one more for my exponent, so that'll be times another negative 2. And obviously that's to the 1. So let's do our 64 times our 64. Did just figure that out over here. So that's going to be 4096. And then we need to multiply that by negative 2. So let's work that out. We'll obviously get a negative answer. 2 times 6 is 12. 18 plus 1 is 19. 0 plus 1 is 1. 2 times 4 is 8. So this will be negative 8192. Okay, the final part is to simplify each equation, then solve for the value of the variable. So if I use a little bit of test-wiseness here, when I look at 32, there's only one base who's can make a value of 32 by powering it, and it's got to be base 2. So I think the k should be 2, but let's check either way. Let's start by multiplying these powers with the same base. That means we'll add their exponents. So 6 plus 4 is 10. When we divide powers with the same base, we're going to subtract their exponents. This is k to the 5. And then we want to ask ourselves what 5 factors would multiply together to give us 32. We could, of course, break this down into its prime factors. And hey, look, 5 factors of 2 make 32. So we know it's 2 to the 5. That gives us 32, even if we didn't have that memorized. Take a look at question B. We're going to start inside the brackets here on top. So m cubed times m is m to the 4 inside the brackets. Let's do some simplification on the bottom as well. I know m to the 0 is 1, and multiplying by 1 doesn't change anything. I also know m to the 8 divided by m to the 4 will be m to the 8 minus 4, which is just 4. On top, multiply the exponents, m to the 12. And 12 divided by, m to the 12 divided by m to the 4. We're going to subtract those exponents to get 8. So again, we want to think about what would we have 8 equal factors of multiplied together to give us our 256. So let's think about that for a minute. I do know that 256 is 16 times 16. That's one of my memorized facts from grade 8. I know that each of these 16s is 2 to the 4. So I'd have 4 factors of 2 from each of these 16s. That makes 8 factors of 2 in total. And that's going to tell me that 2 to the 8 is equal to 256. Therefore, m must be 2. So on both of these questions, we happen to have a base of 2. Obviously, 256 could have had other bases. It could have had 16. It could have had 4. So there's a few different bases it could have been to get our 256. In this case, it happened to be base 2. So I hope that quick overview has helped you with some of those questions. Make sure that you know your exponent laws really well for your exam, so that you're not having to spend a lot of time trying to remember, oh, what do I do with the exponents when the powers are multiplied, so on and so forth. Good luck with your studying.